Hi everyone, welcome to Integral Calculus. Today we explore section 6.2, setting up volume by washer method. Now, for the following example, we have the same exact bounded region. The goal to set up the integral to compute the volume by rotating the bounded region around a specific axis. In the first example, let's rotate the bounded region about the x-axis. So we can sketch out a sample washer that looks somewhat like this. This is the outer, and this one is the inner. Yeah. Look at the outer radius R. The outer radius is y equal x squared plus 2. So that will be a x squared plus 2. The inner radius is this one. And there is 1. So inner radius just 1. The volume here is, we got to integrate the sample volume from 0 to 2. So 0 to 2 sample volume. That is the volume of a washer. Integral 0 to 2. Volume of the washer is the pi r square minus the small r square dx. And we have x squared plus 2 square minus 1 square dx. Yep, by this is the setup. Let's move to another one. Now, in this example, let's say that we're gonna rotate the bounded region about the line y equals 6. So when we do the rotation, this would be a washer. Here's the sample washer. Yeah. Let's take a look at the outer and the inner radius. This is the outer radius right here. It's 6 minus 1. Which is 5. The inner radius is the smaller radius. This is the smaller radius. It's 6 minus x squared plus 2. Yeah. Well, to simplify this to be 4 minus x squared. And then from here, volume is, we're gonna sum up these volume of washer from 0 to 2 sample volume. Integral 0 to pi r square minus the small r square dx. And that'd be 0 to 2 pi. The bigger radius is 5 square. The smaller radius is 4 minus x square. and square dx. That is it. That is the setup. Pretty cool. Now it's gonna get a little more difficult. In C, we rotate about it region about the line x equal 3. So when we do the rotation, just be very careful, right? There are two regions. It's the region 1 and the region 2. Meaning that when we sketch out the sample washer, there are two of them. One of them is in region 1 and then the other one is in region 2. So here comes the first sample washer. And here comes the second one. Let's take a look at the washer in the region above the line y equal 2. We see that this is the outer radius R. And it's going to be the difference between 3 and this distance x. This x, this whole distance here is 3. So that's just the difference between 3 and x. We can solve for x here. Well, y equals x squared plus 2. So x equal to root of y minus 2. And 3 minus root y minus 2. The smaller radius R is this one. Well, that is just the difference between 3 and 2. 3 minus 2, which is 1. Now, for the washer below, the outer radius is this one. So as you can see, that is exactly 3, a distance of 3. The inner radius is this one. So that is the distance of exactly 3 minus 2. That's 1. Oh, once we have this, we can set up the volume. So volume is the volume 1 plus volume 2. Volume number 1 is integration of, well, we got to integrate the volume of sample washer from 1 to 2. So integral from 1 to 2. Pi r square minus r square dy. For the second integral, it's going to be integration from 2 to, when we do the substitution for x equal 2, this would be a 2 square plus 2, which is 6. 2 to 6. Pi r square minus the small r square dy. Integral from 1 to 2 pi. The bigger radius is 3 minus root of y minus 2 square. Smaller radius is 1 So 1 square dy plus the integral from 2 to 6 pi. The bigger radius is 3 square, the smaller radius is 1 square dy. Yay, this is the setup. Cool. One more. Now, let's say that this D here. We want to rotate the bounded region about a line x equal to 3. So same thing here, if we do that kind of rotation, there are two different regions. So we're going to rotate the first region about the line x equal to 3, which is going to give us a huge sample washer. Let's sketch our sample washer here. Okay, so this is the first sample washer. When we rotate the region above, we're going to get another sample washer. And then you can see the sample washer is just by rotating this horizontal stripe. Actually, it is good if you guys sketch out the stripe, because it will help us to sketch the washer a little bit easier. Oh, my scale is pretty bad. Take a look at the one on the top. From here to here, that would be the bigger radius. And as you can see, that would just be 2 plus 3, because from here to here, this is the distance of 3. Bigger radius is 2 plus 3. That is 5. The smaller radius is this one. So it looks like that we have 3 plus this distance right here is x, 3 plus x. And we know this curve is y equal x squared plus 2. So x is root of y minus 2. X plus 3 root of y minus 2 plus 3. Okay. Okay, let's take a look at the sample washer below. This would be the outer radius, 3 plus 2, or 2 plus 3. The inner radius is this one. That's exactly 3. So outer radius is 5, inner radius is 3, and then from there, we'll be able to figure the volume. Volume is the volume 1 plus volume 2. So the volume 1 is the integral from 1 to 2. Pi r square minus r square dy. Volume 2 is from 2 to this intersection right here is 6 pi r square minus r square dy. Now do the substitution. 1 to 2 pi. The bigger radius is 5 square minus the smaller radius is 3 square dy. Integral from 2 to 6 pi. The bigger radius is 5. That's r square, 5 square. Smaller radius is root y minus 2 plus 3. And square it dy. Yay! And this gives us the answer. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.